Okay, so our last application is finding the distance between 2 points in our xy plane. So we'll start off with an example. We'll talk about what we're doing, and at the end of this, hopefully we'll have a nice little formula that we can use. So let's start by plotting these points. So when I go to an xy grid, right, we're talking about -1, 2, so there's that point. And then we're talking about the point 2, 1, 2, 3, 4, 5, 6. So there's that point, right? So 2 and 6. Alrighty? And so what we're asking for is the distance between the 2 points. Now, it turns out that that's a loaded question, all right? Because that distance can be just about anything, you know, because it kind of depends on what path did we take to go from here to there. All right, and so, you know, we could be, you know, crazy and go along, you know, walk around, all of stumbling around till we get there, right? Or we can dogleg it over there, or we can go straight to the point. And that's basically what we mean by the distance. We're looking for the shortest distance. And the shortest distance between 2 points is always going to be a straight line. So there's what we're looking for. We're looking for that distance. Okay, so how do we find how far they are? Well, what we're going to take advantage of is we're going to take a look at the idea that if I dogleg it over there, and this is going to feel and look a lot like slope, but make sure you know we're not talking slope here, because slope is a fraction. But I can basically dogleg it over there, and so I can start walking this way first, and then walk upwards next, and lo and behold, what I just created is a right triangle. And so I can literally just count it, 1, 2, 3, right? So this side is 3, and then I can count it, 1, 2, 3, 4. This side is 4, and lo and behold, what I have is my Pythagorean theorem now, because I was able to draw a right triangle situation that included the distance that I was trying to find. It happens to be the hypotenuse. So if I plug in numbers, right, we get 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. We get c squared equals 25. Taking a square root, introducing our plus minus, keeping the positive root, the distance between these 2 points is 5 units. So that's 5 units away. Okay, so it's kind of like the little, almost like the GCC pool problem, just oriented the other way. Okay, so that was really nice because the numbers came out nice. What if we have a situation that's really, really crazy, right? So what do we do with that? Well, let's go ahead again. Let's borrow that information from slope. It turns out that this side right here is our change in x, right? That's how far we moved in the x direction. Now, in the slope formula, that's basically my x coordinates subtracted from each other, x2 minus x1, just like we did in the slope. In this case, it would be 2 minus -1, which becomes 3. And then this distance right here is our change in y. Well, the way we calculated the change in y was we took our y2 minus our y1. And so that basically became, in this particular example, that'd be 6 take away 2, which is 4. All right? But what I'm going to do in formula form, so we can use this for any 2 points, this is my A and this is my B. So when I come back over to my Pythagorean theorem, this is what it's going to look like now. A is x2 minus x1 squared. B is y2 minus y1 squared. And how about I call C? I'm going to call it D for distance, right? And so we have D squared. And what we have here is a formula. X1 and y1 and x2 and y2 are any 2 points you can dream up of, including the 2 that we're dealing with here. All right. However, this is the way I like to remember the formula, but to solve for D, we're going to take a square root. And keep in mind, when I take a square root of, I introduced a plus minus. But since we're talking distance, we're always going to have the positive root. So when you guys look this up in the book, or when you guys look it up in the internet, you will probably see the formula written like that. All right, and it looks a little harder, a little daunting, but it truly is. You're going to have to take that square root at some point anyways. But I always just felt that with formula was easier to remember this way. And then for those moving on to higher math, it's actually the equation of a circle. So there's a lot of, things, lots of thoughts there that I'm throwing at you, but you use whatever formula you want. All right. So the one where we keep the squares, or the one with the square root, and all we need to now do is use it. So if we had to come up here, here's my x1 and y1, here's my x2 and y2. So my distance, if I plug everything in, right, it's x2 minus x1 squared plus my y2 minus my y1 squared. We would get, this is 3 squared, this is 4 squared, and you guys can hopefully see it coming up. So d is the square root of 25, d is 5. So that's how the formula would have come without all the nice little drawing that we have here. So there's our formula. We obviously have to practice it. I'll do that in the next video.